Okay, this is example 1 in 9.3 for Math 20-1. It's where we actually start to graph some of these quadratic inequalities in two variables. And this really makes it, the example title is super specific. It talks about when a is less than 0. I just do want to remind you, this is some of the chapter 3, that if we look at a parabola in our vertex form, then if a is less than 0, we know that this parabola opens down. The other pretty important concept that's creeping in here from chapter 3 is our vertex is always at p comma q. And I know that this question doesn't ask for it, but if I look at the graph of y is less than -2 times x minus 3 squared plus 1, the first thing that I'm going to do is I'm going to draw y equals -2 times x minus 3 squared plus 1 with a dotted line. And I always like, I usually ask this in class, why is it a dotted line? Why not a solid line? Make sure you do understand that because that inequality, it's not equal to, points on the line aren't valid. So the dotted line is that visual technique we use to show someone reading the graph that any point on the line does not solve or satisfy this inequality. Now, in order to draw this equation, and this is where the chapter 3 is super helpful, we can identify that a is -2, p is +3, and q is +1. If you are struggling with that, you need to go back and take a look at the chapter 3 materials one more time. There is a reason we do chapter 3 before this chapter. You have to be pretty comfortable with quadratics. And I'd like to just kind of summarize what this means. A is less than 0, so a is negative, means that the parabola opens down. If p is 3 and q is 1, that tells me that my vertex is at 3 comma 1. And that's really all we need to get a pretty, well, maybe not accurate is the right word, but a fairly reasonable graph of this. I would find the vertex at 1, 2, 3 comma 1, and then I would just move my parabola or open my parabola downwards. Now it's worth mentioning that because a is larger than 1, this parabola is more narrow than y equals x squared. We'll get much more into that in Math 30 though, so don't worry too much about that. Another thing that some students struggle with is the idea that I don't really care what the x-intercepts are. Unless there's something about this question that tells me, maybe just as an example, y also has to be greater than 0, and then we the overlap of two solutions, then we would care about where the x-intercepts happen. But just drawing this inequality, that's enough. The one major mistake I made, and this is on me for sure, is I forgot to make this a dotted line. Right? That graph is y equals -2 times x minus 3 squared plus 1, but it's very important that that does need to be a dotted line due to its inequality. So I'm going to try that one more time. There's my vertex, and then I'm just going to kind of perforate or dot that line as it goes downwards. All right. We need to decide if we shade in, I always like to talk about or tell students, you are deciding if you're shading above the vertex or below the vertex. Now, because we know that vertex is at, and I'll put it right here, we know that that's at 3 comma 1, it should be relatively, maybe not simple, but hopefully direct to understand how to get points above or below the vertex. Above the vertex, I would just add 1 to the y. Below the vertex, I would subtract 1 from the y. Now, there is another way to determine where we shade this graph. Because y is less than the function, we would shade in below the function. I'm going to do that in a different color. This blue shading is the inequality solution region graphed. Now, really what I'm saying by shading that is that 3 comma 0 should satisfy this because it's inside the shaded region. We can check that through substitution. So is 0 less than -2 times 3 minus 3 squared plus 1? All I'm doing there is putting 3 in for x, 0 in for y, and I get that 0 is less than, well, 3 minus 3 is 0, so this whole term is 0, and I get that 0 is less than 1. Is 0 less than 1? Hopefully you all agree it is, so that should be part of the solution region. Nothing wrong with continuing to use test points, although you do want to try to work towards the point where if you have y isolated, if y is greater, we shade above. If y is less, we shade below. And we certainly see that y is less than the function in this question. All right, last part then is B, which is really kind of a verification question. It wants us to determine if the point 2 comma -4 is a solution. It is a solution if when we substitute into the inequality, it gives us, when simplified, a true statement. So what I'm going to do is I'm going to put -4 in for y, and I'm going to put +2 in for x. And I'll really make sure I write out all the steps for this one. So this is going to be -4 less than, the -2 is going to be multiplied onto -1 squared plus 1. Really important to do exponents before multiplication. So -4 is less than -2 times +1 plus 1. I get that -4 is less than -2 plus 1. I get that -4 is less than -1. Now, -4 is less than -1. That's true. And if we looked at our graph, 2 comma -4 is somewhere right about there. And maybe that was the wrong color because we can't see it, but 2 comma 4, I would say, is somewhere right there. And if you do have, a good graphing utility or a reasonably accurate graph, you could use that shaded region to determine if it was a solution or not. The one thing you have to be careful of is that there are a lot of points that are very close to this line. Just as a quick example, I am honestly not sure if 4 comma 0 is above or below that x-intercept. So when in doubt, substitute into the formula and make sure you can evaluate or verify with that technique, the algebraic technique.